Okay, welcome back. We're on page 229, talking this time about the parameters. So there's two parts to the parameters. A pair, the data type, and then this brand new variable name. And I mentioned to you guys, the variable name does not have to match. In other words, my friend does not have to match is friend, and name doesn't have to match first name. They don't have to match. Okay, cool. Now, parameters are there's a phrase here, it's kind of sort of important, so pay attention. It's called pass by value. Okay, so let me give you an example. I'm going to do yet another one of these goofy little things, except this time I'm going to say public void, I'm going to call this one add 2. I'm going to take int, I'm going to take value, and then I'm going to say, value is equal to value plus 2. Okay? That's it. Now, I don't have to have a return statement. I could have a return statement with a void, but I don't have to. If I have a data type, then it must have a return statement. The only place where you'd want to have a return statement with a void is if you're trying to get out of the loop or get out of the method early. You would have to use the word return. Okay, so let me go back up to here. And I'm going to do another one. I'm going to say, these variable names are stupid, but let's say int is equal to 12. Cool. And then I'm going to call add 2. I'm going to pass it demo2. And then when I'm done, I'm going to turn right around and ask me what the value is. Okay, so let me tell you what's happening here. What's happening is when I pass the value of 12 to this method, it's making like a Xerox copy, okay? So I have the original. I have a piece of paper that has the number 12 written on it. And before I give it to you, I go make a Xerox copy and then hand you the Xerox copy. Now, you're free to erase the 12 and type 13 in there or 14 in there, but it does not change my version, right? Because you just have a Xerox copy. Okay, so here I have a demo 2, and it's equal to 12, and I send it down here where I'm supposed to be adding 2 to that thing. Cool. And then I'm going to display. All right, let's run this guy. So what's it going to be? Is it going to be 14? Actually, it's not going to be anything tall. It's demo 2 is 12. So demo 2, I should have done a pin, shouldn't I? Yeah, let me fix that real quick, because I like to be able to see them all. All right, hang on. Got it. There we go. That'll make this a little bit more better. All right, the point of this thing was it did not change. Demo 2 stayed 12. It did not go to 14. Why? Because down here in this line 52, I'm working on a Xerox copy, not the original. Up here is the original. Okay? That making sense? And again, doesn't matter what the variable names are. I mean, if I was to change this to value, it wouldn't matter, right? I'm just making a Xerox copy. Okay, I'm going to run this one more time just so I can see both of them. Yay! Okay, cool. Is this making sense? What does pass by value mean? That means I make a Xerox copy before I give it to you. Therefore, you can chew it up, spit it out, change numbers. I don't care. My version doesn't change. You can have whatever the heck you want with your version. Okay, on page 230, they talk about the body of the method. This is obviously where the code is, right? Because you want the method to do something like add 1. Or, in this case, something stupid. Okay, so typically there's a return statement, particularly if it has to have a return statement, if it has a return value. If it doesn't have a return value, then the return statement is kind of optional. In fact, if I put a return here, I mean, it's okay. I mean, it's perfectly okay. The machine might actually come back and say, that return is kind of not needed. But, maybe you like to see it that way. So it's just a plain old return with nothing being tacked onto the end, no argument to the return guy. Okay? Okay. So let's do some real world examples. There are real world examples on page 231 are pretty skimpy. So I'm gonna do a couple, and then I'm gonna let you do the rest, and then we're gonna get back. So I'm gonna do the one about get area of a circle. Now I don't like get. Okay, I don't like the word get. So I'm gonna call mine calc area circle. Okay, so I'm gonna do this, and it's probably gonna be a double. And I'm gonna call mine calc circle area. And all you do is you give it the radius. Now, it would kind of make sense to call this thing radius. All right? That way, I don't have to have any documentation. In other words, when you use the calc circle area method, you would see that it's asking for a radius, and you go, this could be kumquat. This could be value. It could be anything, but making the name of the variable radius provides you some information. Okay, that makes sense? Now I'm going to do it the kind of slow and easy way. I'm going to do double answer. Okay, that's just me. You don't have to do that. This is just the way that I typically do things, and then not exactly, but it's close. Okay, so double answer, and it's going to be, okay, so, remember pi r squared and cornbread r round, that kind of stuff. So I'm going to do 3.14 times the radius. And I'm just going to do times radius because I don't want to have to do the squared. Okay? Dang it. Dang, if I could type. Okay, so now I've got this thing. Now, I'll admit, this is not complicated, but let's just pretend up in here that you were doing this over and over and over, and you don't want to duplicate code. Let's say there was 15 of these circles that you had to calculate the area on, right? Okay, so I would do something like et display append area 1 is equal to calc circle area, I don't know, let's do, 2.5. Okay. Plus a closing new line. Okay, now that by itself, that's not tough, right? I mean, you're not really saving yourself anything with having a method. But if I had this over and over and over, well then I don't want to have that formula all over the place. I'd rather have it set up so that I have all of my calculations done in one place. So I'm just going to make this one, 5, and make this one a 6, and make this one a 9. I don't care what it is. Okay, now do you understand why I'm doing it? So the purpose for having a method is that all of my calculations happen here, and I can use it over and over and over without having to copy the formula. Okay, I'm trying to reduce the amount of duplicated code. That's what the method is for, is to reduce the amount of duplicated code. Oh, I made 2 of them 9. Whatever. Okay, so one more time. What's the purpose for this thing? Was to reduce the amount of, if I'm going to be calculating the area of a circle over and over again, I do not want duplicated code. Okay, good, all right. Now, variable scope, we kind of sort of talked about this, but this is, so one more time on page 233, every variable has a lifespan. So for example, right here, I created a variable, okay, and its lifespan is from that point on until the ending closing brace. That's it. That's its lifespan. In other words, no one else can see what demo 2 is, right? If I go down here and say, hey, what's in demo 2? If I said demo 2 is equal to 12, the machine's going to say, what are you talking about? I don't have anything called demo, because it can't see that guy. All right. Because it was created here. Now, if, on the other hand, I had created a variable at this indentation level, okay, like this edit text guy, on line 11, see how he is inside the class, but not inside the method. And so the way that the way that variable scope works is if you declare a variable, it is available at that point, and all the indentations lower, but a lower one can't go back up. Okay, so my friend, it only lives between that curly brace right there and that curly brace, nothing else. But this guy, he lives at that curly brace, which is the entire freaking application, right? Okay, is that making sense? So things that you want to have bigger scope, you put up at the top, and you declare them at the highest level in the in the hierarchy here, inside the class. Okay, is that making sense? Okay, so this variable got created on line 11, and theoretically he dies on line 64. Okay, that's the way that thing works. Now you control the scope by its indentation level. Now I'm saying indentation, but it's not really indentation. Indentation is for the humans. It's really curly braces. Okay. I determine the scope by the curly braces. In my case, the curly braces are indented, so it just makes it easier to say it that way. Okay, so scope is kind of inherited. So if I put high scope, all indentation, everything to the right, how's that from indentation point of view? Everything to the right it can see, but nothing to the left. Okay, got it, good. So remember from chapter 7, we talked about variable scope. I mean, all things that variables have. One of them was all variables have a name. All variables have a data type. All variables have a default value, although the default value isn't all that important. It can mess you up, but they all have them. And so now I'm adding a fourth one. Name, data type, default value, and scope. So now all variables have 4 things. Cool. Okay, the next thing we're going to talk about is overloading. So overloading, there's some terms that you may have seen. For example, up here, I have this thing called override. Well, is overriding and overloading the same thing? No. They both overriding and overloading have to deal with signatures. Okay, so what is a signature? A signature is made up of the name of the method, and then what? The number, types, and order of the parameters. Okay? Good. All right. So, let's look at this little goofy example. Whoops. Here. Okay, so here's an example of something called print stuff. Okay? And this one has 1 parameter. And here's the same print stuff, and it has 1 parameter, but the data types are different. And here's one that says print stuff, and it has 2 parameters, 1 with an integer and 1 with a string. So each one of these signatures are different. Okay? Do you see how they're different? This one has 1 parameter, it's an integer. This one has 1 parameter, it's a string. This one has 2 parameters, one of them is an integer, one of them is a string. So the method signatures are different, which means this is what's called overloading. So print stuff has been overloaded by using a different, same method name, but the parameters have changed. Therefore, this does not cause any problems. There's no way that the compiler is going to come back and say, oh my God, you got 3 methods with the same name. You can't have that. No, because their signatures are different. This is perfectly okay. Now, contrast that with overriding. Overriding has to have the exact same signature. Okay, one more time. Overloading must have different signatures. Overriding must have the same signatures. Let that sink in. Hey, we're coming up on the 15-minute mark, so you're going to have plenty of time to let that sink in.